I'm inside Math XL again. This problem was sent to me by a student who said that she has no trouble solving this, but she has problems writing the answer, the solution set. And so I wanted to essentially address her concerns. So I'm not going to solve this one per se. I've already done that right here, but I am going to talk about a few things. And first off, this is a compound inequality because it uses two inequalities connected by the word and. Now it could have been or, but in this case it's and. And of course these two ideas are intersection for and union for or. And I just want to remind you that and is written like this, and starts to get us closer to the symbol that we use in math for intersection. I could write that A like this, nice and rounded, and we're even one step closer to the symbol for intersection, which is this. And keep in mind that the intersection for union, well, it speaks its own name, of course. So these two ideas, though, are worth looking at really quickly. Intersection, think back, let's dial back to the last chapter we had, chapter 3, where we had systems of equations, and we were graphing lines, and the game there was to find the intersection, right, of two lines. That is the one point that these two lines both have in common. And it's the same idea with compound inequalities that use the intersection symbol. We want all the values that work in both of these simultaneously. This is the point that is on both equations simultaneously. We want all the solutions that are in work for both of these simultaneously, and that's what the word and says. It has to be simultaneously. So I went ahead and solve this one here for x, and there was no extraordinary moves there. This one though, when I subtracted 8 from both sides, I got this. And of course this has that one move that we need to talk about. That is when I'm going to divide both sides here by -5. And when you divide or multiply by -5 inside an inequality, you have, to both sides of course, you need to reverse the sense of that inequality. So when I divided both sides by -5, I did that. And of course a negative divided by negative is simply 1. And now we have this interesting thing now. Notice this, when I have x, the unknown on the left, this is only for when it's on the left, isolated on the left, and in both situations I have it isolated on the left. When you have that situation, the inequality is basically an arrow pointing in the direction of the solutions go. So this is saying from -5 that way to the left as far as you want to go. And this one is saying from 1 to the left as far as you want to go. Now when we graph these simultaneously, we're going to be looking for the overlap, the intersection. And so when we graph this one, everything less than -5, we're not going to include -5, so we're going to use the open parentheses, and it's everything this way. And now when we graph this one, it's everything to the left of 1 excluding 1, and so that's going to use this symbol, and I want to include 1 there. I'm trying to get that to look nice. Now it's everything this way, and so we're wondering where is the overlap of these two. And the answer is from here to the left. And we don't include -5 because -5 is not a solution for this one. So we still need to use that. And then it's everything to the left, and we use the negative infinity symbol for that. So there it is in interval notation. And we would say, type your answer in interval notation. That's what they want to see. And so that's how you solve these. Now, before I turn you loose, let me show you the Wolfram Alpha page. It can handle and or. So here's the two inequalities, and is the connector. And notice the same solution here. Everything less than -5, excluding -5. And here's the x is less than 1 graph. Here is the x is less than -5 graph. And of course it's going to be the overlap, just like this. Okay, I hope that helps. Thanks for sending me the problem.